Hi everyone, welcome to the channel. We're going to be solving question 4 from the chapter 7 of Beer&Johnston textbook, Engineering Mechanics, and we need to determine the internal forces at point J when the angle alpha in here is equal to 0. So basically the force 780 newtons that we have is going to be in this direction, 780 newtons, so forget about this part. And we're going to start with the free body diagram. We have two different supports at point A and B, and we need to find the unknowns at those 2 points. At point A, since we have a two force member between A and C, we can just consider one force A in here, and at B we have a pin. So we're just gonna do two forces Bx and By, and after we find these reactions from the free body diagram of entire system, we can move on to the section Bj in order to find the unknowns that we have or the internal forces at point J. But before doing that, let's just find all the reactions that we have in here. So we are in equilibrium. We can use our equilibrium equations. So we have sum of all forces equals 0, and we have the same thing for the moment. Let's start with our moment equation first. Sum of all moments, we're going to do it about point A. And the reason is that we're going to get rid of A. We're going to get rid of Bx since it's going to pass us through A. So no moment from Bx. We have the moment of By, which is in this direction. So it's counterclockwise moment, and we call that positive. So By times the distance, 300 millimeter divided by 1,000, it's going to give us meter. And we also have the moment of 780. This one's also counterclockwise. So plus 780, that's the force, and the distance that we have for the moment is the vertical distance to the line of action, or what we have from A to D. So it will be 480 plus 240, which will be 720 divided by 1,000. And that's pretty much everything for the moment, equals 0. And from here, we can find our By. We didn't need to do unit conversion because it will be canceled out at the end, but just to be safe, we did the unit conversion too. So it will be minus 780 times 720 divided by 300. Let's see what we get. 780 times 720 divided by 300. That's going to be 1872, and we have a negative sign that shows that our assumption for By was not correct, and it's actually downward. So By is 1872 newtons. And now that we have By, we can do sum of all forces in Y direction. This will be our positive for Y. So we're going to have the Y component of A, and in order to find that, let's call this angle here alpha, which is what we have in here. And if we want to find that angle, we have this right triangle, which has a base of 300. The other side is 720, and we can find the hypotenuse. So based on the Pythagorean theorem, we have the square root of 300 squared plus 720 squared. That's going to be 780. So now we can find the x and y component pretty easy. So for A, the y component would be a sine of alpha, and the sine of alpha would be the opposite over hypotenuse, or 720 over 780 plus By, which we found is minus 1872. And that's pretty much everything in y direction, equals 0. Now we can find A, which will be 1872 times 780 divided by 720. So 1872 times 780 divided by 720. That's going to be 2028 newtons, and no negative sign. That shows our A was in a correct direction. And we have one more, and that would be our Bx. So if we do sum of all forces in x, this will be our positive x direction. We basically have Bx plus 780, plus 780, and we also have the x component of a, which is to the right too, so 228, which would be 8, and we have cosine of alpha in order to get the x component. Cosine of alpha would be the adjacent over hypotenuse. This will be equal 0. Let's see what we get for bx. So 228 times 300 divided by 780. That's going to be 780 plus 780. It's going to be 1560, but it will be negative since it will go on the other side of the equation. So minus 5060 newtons. And the negative sign shows that the bx is actually to the left, and our assumption was incorrect. So now we have all the reactions. If we pick this part of the member BD, we can find all the internal forces at point J. So we're gonna draw the free body diagram of BJ. So this is our member, and the forces that we had was our BX, which was 1560 Newton. We found our BY downward 1872 Newtons. And the forces that we have at point J, we can consider one force F, one force V perpendicular to that one, and a moment. And that's going to consist all the internal forces and bending moment that we have at point J. So as we discussed in the previous questions, we're going to define different x and y for here. I'm going to call this x prime and this y prime. And the reason is that it's going to help us to solve our equations because we have our equilibrium equations again. And this way, our f and our v will be in x prime and y prime direction. So it's gonna be easier to solve the equations. But before doing that, we also need to find the x and y component of each of them. So obviously the 1872 has x prime y prime component, and we have the same thing for, so we just have to keep in mind for these. But what we found in the previous step was the angle alpha, which we have what's in here alpha. So the angle that we have was the angle between x prime and the 1560 force. And if that angle is alpha, this one over here is alpha too. So the rest of this is just doing sum of all forces in x prime equals 0, and we're gonna have the same thing for y prime too. So let's start with the x prime. So we have f minus 1560, the x component be cosine of alpha, which is, if we get back in here to this right triangle that we had, cosine of alpha would be 300 over 780 minus 1872. That one would be the sine of alpha. Sine of alpha would be 720 over 780 if we get back to this right triangle that we have, since we have the same alpha. So this will be equal 0, and we can find f in here. So our f is basically 1560 times 300 divided by 780 plus 1872 times 720 divided by 780. So our F would be 2328 newtons. And if we want to show the angle, we're going to have the same angle alpha here. And for finding the alpha, we can just get back in here and find the alpha very quick. Alpha would be basically tangent inverse of 720 over 300. Let's see what's that. So this will be 67.4 degrees. And for the rest of the calculations, we can use that angle too. So 67.4 degrees. So that's our F. So one forces out, and we're gonna do the same thing for y prime. So we're gonna have the y component of 50, 60. Again, we can just go straight with the sign of alpha here, or get back in our triangle and find sine of alpha, which is 720 over 780. So that's positive because we have this one, which is toward the positive y prime axis. We have minus 1872 times, we're looking for this one, which would be the cosine of alpha. So 300 divided by 780. And we have also v, which is downward, or along negative y prime axis, equals 0. And we can find v in here, which will be 1560 times 720 divided by 780 minus 1872 times 300 divided by 780. And this is going to give us 720 newtons. And if we want to show this angle here, we know this one's also, so this angle is also alpha. So if you want to find this one, we basically have 90 minus 67.4, which is going to be 22.6 degrees. That's our V. And we just have to find the bending moment. So we're going to do sum of all moments about point J, counterclockwise positive. We have our M, which is the bending moment that we have. And we have the moment of the 1560, as we can see, it's in this direction, so counterclockwise. So plus 1560 times the distance would be what we have in here, which we have to figure it out. So we are looking for this distance, 480. So times 480 divided by 1,000, since it's millimeter. And we also have the moment of 1872. This one's clockwise, so we have a negative sign, minus 1872, and the distance would be the vertical distance to the line of action. So the vertical distance from G to the line of action, we're looking for this distance, which is what we have from here to here. And for finding now, I'm just going to clean up the figure. We can see it better. And the distance that we are looking for is this one, which we can call it A. And we have this one, 300. And we also have this side, 720. And this one, 480. So since we have two similar triangles, we have 480 over 720, which is equal to A over 300. So the A in here would be 480 times 300 divided by 720. So our A would be 200. And that's exactly what we needed in here. So we were trying to figure out this distance, which is 200. So times 200 divided by 1,000, since it's in millimeter. And this will be equal to 0. And we can find our M here, minus, so we have 1560 times 480 divided by 1,000 minus 1872 times 0.2. So our moment in here would be minus 374.4, and the negative sign in here shows that the moment, so Newton meter, and we got a negative sign, and our assumption was, and we considered counterclockwise positive, so the negative sign in here shows that we have a clockwise moment. So yeah, that's pretty much everything for this question. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next one.